Welcome, Math 1111ers. I don't have anybody in the room right now. Hopefully I'll have a few people trickling in, but I'm going to go ahead and get started with the lecture over 1.4. If you're watching this and want to follow along, don't forget I've posted the PDF of the notes that I'm going to cover here in D2L. So I'll just go ahead and get started. Okay, so the first concept that you encounter in 1.4 is the idea of a scatter plot, or looking at data on a graph here. So I have an example here of percentage of adult females who are literate in regards to child mortality rates. So this is real data. You can see that the source comes from the United Nations there. So I'll just talk to you a little bit about what you're looking at. You're looking at the data that was gathered. So you can see that the data trends downwards. In other words, the higher the percentage of females who are literate, it appears that the lower the child mortality rate is, and we're talking about children under 5 years of age, and that's per 1,000. So not 250 children there at the y-intercept, but 250,000. So a scatter plot would just be the axes and the red dots there. So just a scattering of points that represents data. I'm not going to write these definitions out. You can write them out yourself on your notes if you'd like to. Now the regression line. The regression line is the blue line that's running through the data. So let me talk a little bit about that, what it exemplifies and how you get a regression line. So you can see that the blue line running through sort of halves the data points. It sort of runs in the middle of the data. That's exactly what you want a regression line to do. It's not going to give you exact data values except for 2 of them. Welcome, Dave. I've just started talking about this first concept. You're the only one in the room, so just let me know if things aren't making sense to you as usual. Okay, so I'm talking about the blue line, the line of regression here. So I've got all these data points scattered. To find the regression line, you're trying to find the line that is most representative of all the data. So that's why it looks like it runs through the center of the points there. To find a regression line, you simply choose 2 points that look like they're in the middlemost part of the data. So it looks like this regression line was done using those 2 points that I've just highlighted there. And I'm just guessing with that. It could have been the one next to it. It could have been this point right here. In any case, though, you only need 2 points to write the equation of a line. So any 2 points that look like they hit the middlemost part of the data, you pull those 2. We're going to learn later on in this particular section how to write an equation from those 2 points, but that's how a regression line is fitted to a data set. You just choose the middlemost points. You're going to have outliers. We could have had a data point there, and that would be an extreme outlier. But you know, you have some that fall above and below, and your line of regression is supposed to fall at the middlemost, representing the most data points. So you can see how the points kind of gather around that line. Okay, I'm going to go ahead and move forward here. All right. So there are some things about lines that we need to understand before we can start writing equations of them. And the first concept that we really need to have a good grasp on is slope. So in casual terms, I would say that slope is an incline of a line. in more technical regards, you're talking about the vertical change of a line over its horizontal change. That's where we get the whole rise over run definition for the slope of a line. You can see right here we have the change in y, so that's change in vertical position over the change in the horizontal position. That can also be written like this: delta y over delta x. That triangle delta just means change in. So we write things like that as mathematicians to make ourselves feel smarter than other people. No, I'm just kidding. As mathematicians, we're known for like using symbols and cramming 3 pages worth of material into 1 paragraph using symbols. So this is just another way to write change in y over change in x. Okay, so let's explore the concept of rise over run a little bit more so that we can figure out how this formula that we get for calculating slope comes about. So we'll start off by naming 2 random points on the line. Remember, I said 2 points determine a line. That's how you can write the equation of any line, is having 2 points. So this is the point x1, y1. Those ones are just a naming system. It's just saying the first point. So the x value of the first point, the y value of the first point, x1, y1. And then we have our second point here, x2, y2. Once again, just a naming system. All right, so if the first thing that I want to figure out is my change in vertical position, I'm talking about the distance between, the vertical distance between my 2 points. So I'm talking about this distance right here, that up and down distance. If I said to you I came onto campus with $10 in my pocket, I went to the bookstore and I now have $2 in my pocket, and then I said, what's the change that occurred in my pocket? You would say $8. How you got that was you took my first amount, $10, you subtracted where I ended up at to get that middle, the change between what I began with and what I have now. You subtracted to do that. That is why the formula for slope has subtraction in it, because you're trying to find the difference between your positions there. So we always denote slope with m. I've been told different stories about why it's m, but the one that I cling to the most is that it's actually, I forgot I put it on the page here, it's actually the French verb meaning to rise or ascend, monter. Also, the French word for mountain or slope is montagne, I think, something like that. But m is what we use for slope. So, when I want to find my vertical distance, I need to subtract where I started from where I ended up to find that difference. That's why it's y2 minus y1. And then the same thing in the x direction. I want to find the change in my horizontal position by subtracting where I end up from where I began, and you get that difference between there. So hopefully it makes a little more sense now why you subtract those values when you're trying to find slope, because you're trying to find the difference in, and difference means subtract, the difference in position. Numerator being vertical position, denominator being horizontal position. That's why it's y over x. All right, so I'm just going to do a quick example or two here of calculating slope. All right, so slope equals y2 minus y1 over x2 minus x1. The first thing you want to do, okay, I have no idea why there's a 0 there. We'll just kind of scratch that out and make it 2. First thing you want to do is decide what are you going to call 1, x1, y1, which one are you going to call x2, y2. It doesn't matter because the slope between here and here is the same as the slope between here and here. So it doesn't matter which points you start with. So for simplicity's sake, I'll call this one x1, y1, and this one x2, y2. Okay, so slope is y2 minus y1 over x2 minus x1. Nickel's worth of free advice: anytime you use a formula, write it down. That way you don't have to spend time trying to memorize it. By the time test comes around, you'll just know the formula because you've written it so many times. So y2 is 2 minus y1 over 4, minus 4 over x2 negative 4 minus x1, which is negative 3. Notice that's minus a negative in the denominator there, which is really plus, so plus positive. And I've got an entire lecture over that for 97 students. I'll spare y'all. So I end up with negative 2, because 2 minus 4 is negative 2. Negative 4 plus 3 is negative 1. Negative 2 over negative 1 is the same exact thing as 2 over 1, which is positive 2 slope for that line. Okay, we'll do the same thing for the next set of points. So this time I'll call this one x2, y2, and this one x1, y1. It doesn't matter. Slope is y2 minus y1 over x2 minus x1. Okay, so y2 in this case is negative 2 minus positive 5 over x2, 4 minus negative 1, which is really plus. So I have negative 7 over 5. Just to point out, if I plotted those 2 points, and this is just going to be, it's not going to be exact. I'm just kind of eyeballing it. So the point 4, 2 is probably somewhere right here. So positive 4 down 2, right 4 down 2, maybe about right there. And then negative 1, 5 is left 1, up 5, so maybe here. Notice, use your imagination on that line, by the way. Notice it's going downhill from left to right, and you had a negative slope. Let's take a look at that other example where we found a positive slope of 2. Okay, so I have the point negative 3, 4, so left 3, up 4, probably about right here. And negative 4, 2, so left 4, so just a little more than left 3. Left 4, up 2, about right here. And if I drew that line, you can see that it's going uphill from left to right, and I have a positive slope there that I have calculated. So we can have 4 types of slope. You can have a positive slope, which goes uphill. By the way, you always read slope left to right. So if I'm going uphill, that's a positive slope. Downhill is a negative slope. Zero slope means I have a horizontal line. This is also stated as, and this is confusing, especially because of what the last one's called. This is also called no slope. I'll never refer to it as that because that seems confusing, and this, calling it zero slope, has implications to its calculation. But some people do call the slope of a horizontal line no slope. And then we have undefined slope, which is vertical. Okay, so when you have a positive slope, if you go to calculate it, positive slope, so oops, let me move this out of the way. Okay. Positive slope is always going to be some positive number divided by some positive number or some negative number divided by some negative number, because that's all just a positive number. Positive slope, uphill, positive number. Negative slope. With negative slope, so negative slope, you're always going to get some positive divided by a negative or some negative divided by a positive, because that's all just a negative number. With no slope or zero slope, so when you have zero slope, you're going to end up with 0 divided by some number, some value, negative or positive, which equal, whenever you divide 0 by a number, you just get 0. That's why it's called zero slope. And the last one, undefined slope, so I'll just put UNDM. You're going to have some number divided by 0 when you do the calculation. Division by 0 is undefined. That's why we call this undefined slope, because you can't divide by 0. Everybody good so far? Green check if you're good, red X if you still got questions about slope. Green check, excellent. Okay, so we have 2 forms of the equation of the line. Well, we actually have more than 2. We have 3, but these are the 2 that this particular section focuses on. We have point-slope form of an equation, and we have slope-intercept form of the equation of a line. So I'll write both of them and break them down for you. The point-slope form of a line, it actually comes directly from the formula for slope. I won't go into detail. If you're interested, it talks about it in your book. I'll just give you the formula here and tell you what each of the pieces is. Point-slope form of the line is y minus y1 equals m times x minus x1. Okay, so let me point out the different pieces here. The slope is always m. Okay, so m is your slope. That's the y2 minus y1 over x2 minus x1. The x1, y1 right here, x1, y1, x1, y1. This is a given point, known point, given slash known. Oh, you're right there. Goodness, that should be an N. I have no idea why it came out like that. Given or known point on the line. Okay? And the last thing to point out is this X and this Y right here, those are going to stay. That's where you generate points for your XY table. So you have to have a place to plug in and get Y values out so that you can generate points on your line. So that green XY, that's going to stay there. And that's the XY that shows up in slope-intercept form. What is point-slope form good for? point slope form is a quick way to get to slope-intercept form. Slope-intercept form is one of the easiest forms to graph a line in, and you can tell a lot about a line from the slope-intercept form of it. So if you have 2 points, or a point and the slope, use slope-intercept form to get you to, use point-slope form to get to slope-intercept form quickly. All right, slope-intercept form of a line, let me just give us a barrier here. The slope-intercept form of the line looks like this. Y equals mx plus b. Okay, so m is the same m we talked about above. This is the slope. B that's a B, not a 6, by the way. B is the y-intercept. The y-intercept always has the form 0 and some y value, b. The x and y are the same x and y from above. They stay. That's how you generate points on your line. So this is just the point x, y. It stays, and it generates points. Same thing there. Okay, so are y'all okay so far on the parts of point-slope form and slope-intercept form of a line? Dave says yes. Nick says yes. You can write the equation of a line in all 3 forms, and it's going to be the same line, no matter what form it is. The other form is standard form, ax plus by equals c. Not the most useful form to have the line in, so that's why we don't really focus on it too much in this section. All right, I'm going to move forward. All right, so we're going to start using this information to write equations of lines. The example says, write the equation in point-slope form for the line with a slope of 6 that passes through the point 2, -5. Then write the equation in slope-intercept form. So we're going to use point-slope form, which is y minus y1 equals m times x minus x1. That's a parenthesis. To move down to slope-intercept form, which is y equals mx plus b. Okay? So the first thing I need to do is plug my known information into point-slope form, y minus y1 equals m times x minus x1. Well, that first y stays, so y minus. Okay, y sub 1, here is my known point or given point. So y sub 1, so this is the point x1, y1. y1 is -5. And that equals my slope, okay, so my slope is given right here, slope of 6, times x minus x sub 1 is 2. Okay, so basically I just take this information and move it around until it looks like y equals mx plus b. So the first thing I'm going to point out is that this is really y plus 5, and then I'm going to distribute that 6 to the x and to the -2. And here's what I have. Y plus 5 equals 6x minus 12. And now I want to subtract 5 from both sides. And I end up with y equals 6x minus 17. There's your point-slope form. Notice your slope shows up here in point-slope form, and your y-intercept is negative 17. In other words, if I go and graph this function, it's going to cross the y-axis at negative 17, and moving from the y-intercept, it's going to go up 6, right 1. Real quick, the chart for counting slope off, you always have the change in y over the change in x, and you can have positive or negative values of each of those. Positive y is up, negative y down, positive x right, negative x left. So to graph this thing, what I'd do is I'd put a point on negative 17 on the y-axis, and then I'd move, because I have a slope of positive 6, that's really 6 over 1, up 6, right 1. Or I could move down 6, left 1, negative, negative, because negative divided by negative is a positive. All right, so next example, write the equation in point-slope form that passes through the 2 points, negative 2, negative 1, negative 1, negative 6, and then write it in slope-intercept form. So I'm still going from point-slope to slope-intercept. However, I'm not given 1 point and the slope. I'm given 2 points. So I have to have the slope to write it in point-slope form. So I need to take the 2 points, find the slope first, and then I use that slope I found in either of my 2 given points to go from point-slope form to slope-intercept form. So that's what I'm going to do. First thing I'm going to do is find the slope. Slope is y2 minus y1 over x2 minus x1. Okay, so y2 is negative 6 minus y1 is negative 1 divided by x2, negative 1, minus x1, negative 2. Okay, so both of these are really plus. So that's negative 6 plus 1, which is negative 5, and negative 1 plus 2, which is 1. So I have a slope of negative 5. Now, moving from point slope to slope intercept, for the sake of room, I've got my formulas written here. I would normally rewrite them, but I don't have enough room on this screen to do that. So I'm just going to go ahead and plug everything in. So I've got my slope, and I can use either point. I'll use this first one. They're both on the line, so it doesn't matter which one you use. All right, y that stays minus y1, which is negative 1, equals slope negative 5 times x minus x1, negative 2, which is really plus, so I'll come back and put my plus signs here. So y minus negative 1 is really y plus 1. X minus negative 2 is really x plus 2. So now I'm just going to start simplifying and getting it to look like y equals mx plus b. So this is y plus 1 equals, I'm going to distribute that negative 5, negative 5x minus 10. Then I need to subtract 1 from both sides, and I get y equals negative 5x minus 11. This thing crosses the x-axis at negative 11. From the x-intercept, I would move down 5, right 1, put another point to hit another point on the line. Everybody okay so far with that first one? Dave says yes. Nick says, Nick doesn't say yet. Nick might be out of the room. Oh, Nick says yes. Okay, so gentlemen, if you don't mind, give B a try on your own. I'm going to give you a few minutes. I want you to try to write that equation in slope-intercept. Try to take it all the way down to slope-intercept form. When you get slope-intercept form, type it into the chat window. Don't worry if you're wrong or not. It's not that big of a deal. I'm going to do it here in a minute, but I want you to have a chance to try it on your own. So try writing the equation of the line in slope-intercept form. I will try to find you some equation writing music so that it's not this weird awful hum behind us. And I'll give you a moment. I'm going to go ahead and start working it, but keep working if you're still doing it. I'm actually going to erase above so that I have more room up there. Trying to color code everything here. Okay, so I got everything plugged in. Okay, let me talk about the fraction there. Negative 3/2 times x is negative 3/2 x. Then when I multiply negative 3/2 by negative 4, that's really a negative 4 over 1. And when you multiply fractions, you multiply straight across. So negative 3 times negative 4 is positive 12. And then 2 times 1 is 2. But actually, I can simplify that even further. Okay, Nick, can you simplify first? Yes. You mean the 12 halves? If you thought to be able to divide a 2 out of the denominator and a 4 out of the other one, you could, but being inside of an equation, you may mess yourself up if you do that. I would just go ahead and distribute and then simplify if you can. Sometimes you can, sometimes you can't. So let's see, oops, let me get my black pen back. Y plus 3 equals negative 3 halves x plus 6. Now all I need to do is subtract 3 from both sides, and I end up with y equals negative 3 halves x plus 3. Nick, you are correct. So I know Nick's good. Dave, are you good with that? All right, excellent. I love the smiling face, Nick. All right, moving along. So graphing in slope-intercept form, and I gave you a little bit of a clue when I was talking about it earlier. Slope-intercept form, to me, is the easiest way to graph a line. So your steps. The steps for graphing a line in slope-intercept form. The first thing you're going to do is plot the y-intercept on the y-axis. This is the point, it's 0 for x whenever you have a y-intercept in some y value, 0b. We call it b to match y equals mx plus b, so this is the b I'm talking about, 0b. Obtain a second point on the graph by counting off the slope from the y-intercept. Now, the reason I point that out is because a lot of students will go and mark the y-intercept, and then they'll start counting their slope from the origin, even if that's not the y-intercept, and that's not correct. You know that your y-intercept lies on the line. You're trying to hit another point on the line, so count from your y-intercept, whatever slope your slope is, and then put a point. 2 points determines the line. That's all you need. Y-intercept, 1 more point, so you are ready to graph the line. Don't forget to draw arrows on the end of the line showing that the line continues indefinitely in both directions. So, my slope is negative 3 halves. My y-intercept is 2. So following these steps, I plot my y-intercept, positive 2, on the y-axis. From there, I have negative 3 halves. Now, negative 3 halves is the same thing as negative 3 over positive 2 or positive 3 over negative 2. It's not with both. If you put it with both of them, that's a positive. So choose one or the other. I usually always default to the numerator just so I don't make a mistake. So from the y-intercept, I count down 3, 1, 2, 3, right 2, 1, 2, and put a point. That is the other point, or the next point on my line. Well, it's not the next point, but it's the next point that I'm counting to with my slope on my line. And then you're ready to graph your line. Arrowheads on the end to let me know that you know it continues indefinitely. But my math lab does that for you anyway, so you don't have to worry about drawing them in. So here's the process again. Plot your y-intercept, count your slope, put 1 more point, graph your line. That is how you graph in slope-intercept form, or using slope-intercept form. Green check, red X. Green check, green check. Excellent. Okay. So give this one a try. And I'll turn the music back on for a moment and give you a few moments before I start in on it. It should take you like, 30 seconds to grasp this. All right. How'd y'all do? Dave says yay. Nick says yay. Excellent. Pretty easy. Once you have it in sloped intercept form, plot that y-intercept, count your slope, one more point, and you're done. Okay. We have 2 more slides, by the way. Okay. Horizontal and vertical lines. Let me show you what's happening here. Okay, so notice this equation down here. I have 2x equals -4. All of the other equations we've dealt with have had an x and a y in them. Whenever you get something with just an x or something with just a y in it, bells and whistles should go off in your head. Oh, this is a special one. And that's what leads us to horizontal and vertical lines. So, with this particular equation, I would first want to isolate my variable. So I divide both sides by 2, and I get x equals -2. What this says is no matter what y is, x is -2, no matter what y is. So I'm just going to do -2, -1, 0, 1, and 2. So if I go and I plot these points, I have -2, -2, right there. -2, -1, -2, 0, -2, 1, and -2, 2. And it should come out as a as a vertical line. So, there's a quicker way of doing this. You can set up the XY table and plot your points and you'll get it right every time. But I always also show my students the quickie way. If I have the equation x is -2, that says it goes through the x-axis, through at -2. So, I'll graph it the quickie way now. I'm going through the x-axis at -2. The only way to go through the x-axis is to be going up and down. Okay? So I'll show you the y equals equation over here. So anytime you have x equals a number, it's going to be a vertical line. with undefined slope. Okay, so get another color here. I'm going to isolate the variable here, add 6 to both sides, and I get 3y equals 9, divide by 3, and I get y is 3. So if I were looking at an XY table, this would say no matter what x is, y is 3. So y is always going to be 3 in that case. So if I go to plot these points, -2, 3. -1, 3. 0, 3. 1, 3. 2, 3. You can see you get a horizontal line. Okay. Quickie way of graphing this. Let me clear that off. This says it goes through the y-axis at 3. Well, on the y-axis at 3, there's your point. If it's going to go through it, it's got to go left to right. Horizontal line, 0 slope. Y'all good with horizontal and vertical? Check, check. Yay. We're going to finish early today. Whoopee! Okay? Intercepts. We've already talked about how to find intercepts. To find an x-intercept, you're going to plug in 0 for y. Okay? So you're always plugging in 0 for the opposite one that you're looking for. And for a y-intercept, you're going to plug in 0 for x. That gives you 2 points, and so you can graph your line. Plot both points, graph the line. Now, the only time you can't use this method to graph a line is if you don't have an x and a y-intercept. And that's going to happen in 3 cases. So real quick, before I actually graph these, here are the 3 cases that you cannot use this method. If I have a horizontal line, I only have a y-intercept. If I have a vertical line, I only have an x-intercept. If my line goes through the origin, my x-intercept is my y-intercept, so it's only 1 point there. There's only 1 distinct point that you can find this way. So these are the 3 cases that you cannot use x and y intercepts to graph a line. In any other case, you can. So first thing we'll do to graph this, you're going to find your x-intercept. So in this case, my x-intercept is whatever I get when I plug 0 in for y. So 3x plus 2 times 0 equals 0. 3x plus 0 equals 0. And my x-intercept, oh God, I put an awful, oh, I forgot the -4. I was like, wait a minute, this thing goes through the origin. Why would I put this as an example? I'm sorry. Let me scratch that and start over. Wonderful thing about technology, it erases right off there. First thing I'm going to do is plug in. I know it upsets you to no end, Dave, to find out that I'm human and I make mistakes. Try to hold your tears back, but it happens. It does happen sometimes. Very rarely. No, I'm kidding. I make mistakes all the time. All right. 3x plus 2 times 0 minus 4, there we go, equals 0. So I'm going to add 4 to both sides. And I get 3x equals 4. Divide by 3. X is 4/3, which is the same thing as 1 and 1/3. Whenever you're graphing, that's the only time I'll tell you it's smart to change to a mixed number, because it's easier to think about graphing 1 and some change than 4/3. That just doesn't even make sense to think about. Okay, I'm going to rescale my graph here so you can actually see what's going on. I'm going to put 1 at every 4 hatch marks. So 1, 2, 3. Here's 1. 1, 2, 3, 2. Same thing in the opposite direction. 1, 2, 3, 1. 1, 2, 3, 2. Same thing in vertical and horizontal, or vertical 1, 2, 3, 1. Right there. 1, 2, 3, 2. 1, 2, 3, 1. 1, 2, 3, 2. Okay, so I'm scaling this differently. Every hatch mark you see now is counting for 1. It's quartered up. All right, so, oh, I forgot to do my y-intercept. Let me go do that. That would make sense since we're graphing using x and y-intercept. So the y-intercept is what I get when I plug in 0 for x. 3 times 0 plus 2y minus 4 equals 0. Okay, so add 4 to both sides. 2y equals 4, divide by 2, and y equals 2. Okay, so I have an x-intercept of 1 1/3. I'm going to go ahead and plot that in dark purple. 1 1/3 is about right here on the x-axis. And then I have a y-intercept of positive 2 right here. And then the only thing I have left to do is graph my line between them. So I can actually hit my mark there. Okay, that's it. See if you can do that next one on your own. I'll give you a couple seconds. Only 2 seconds is what you get. No, I'm kidding. I'll give you a minute or so to get your x and y intercept and then graph. And I'm looking for some graphing music for you. Let's see. Oh, that's good stuff. I haven't listened to this in a long time. Which one? They're all so good. Dave says, yay! Nick, what you say, man? Nick says, yes! Awesome! So, Not a difficult section. Shouldn't have any trouble with your homework, especially after the lecture. So the last slide just says, by the way, let me announce, 11:59 p.m. today is the last day you can turn in homework or quiz for Unit 1. Ooh, this should say Unit 2 on it. I'm sorry. I thought I changed everything that needed to be changed. Unit 2. So today is the last day for Unit 1 material. That covers 1.1, 1.2, and 1.3. Homework for those sections. Quiz covering those 3 sections, and any extra credit discussion board points. Everything cuts off tonight at 11:59 p.m. I've had some of you, your classmates, having difficulty with the lockdown browser for the quiz, so I took it off this morning. So if you've been having trouble with that, go in and try again. Don't forget you have 2 chances at any quiz. You don't have to take them. If you take both of them, I'll average the quiz grades to get your final quiz grade. So Unit 2 is going to be due Monday the 10th. So that's 1.4, 1.5, and 1.6. The quiz will open next Thursday, the 6th of February. And it'll be open through the 10th at 11:59. The next lecture is tomorrow here in this room, and I'll be covering section 1.5. Gentlemen, thank you so much for your participation today. Have a wonderful afternoon. You're welcome, Dave. Have a good afternoon. Thank you.